Hello and welcome to 10.2. It's going to be a nice short lesson for you guys dealing with arcs today. Here are the answers for 10.1 day 2 using some Pythagorean theorem, converse of the Pythagorean theorem, and there's some quadratics in there too. So if you need help with those quadratics, make sure to ask me in class. It's something you guys learned last year in algebra. If you need help with this proof, let me know. Back to triangle proofs, proving triangles are congruent to show that parts are congruent. That's been a theme this year. All right, so we're going to be finding arc measurements. As I mentioned, we have two types of arcs. We have minor arcs and we have major arcs. So central angles have their vertice or their vertex on the center of the circle. So this is important, a central angle. It's an angle with a vertex on the center of the circle, and when the angle hits the circle, that creates an arc. And we have a minor arc that's less than 180. We have a major arc that is more than 180, and then we have a semicircle which is 180 degrees. So the arc, the measure of the central angle and the measure of the arc are always going to be the same. And when we're naming arcs, this is important. Minor arcs are always 2 letters. And semicircles and major arcs, we need 3 letters to name them. So that's important. And if we're talking about ADB, so that'd be A to D to B, that would be arc ADB. So that's basically most of the information. Other than that, we just got some sample problems. Most of it's pretty simple. So here, if the central angle is 110, then that means this arc, RS, is 110 degrees. And RTS, so now I start at R, I go to T, and then I go to S. So if semicircle or a full circle is 360 degrees, so I'm going to do 360 take away the 110, that gives me 250. So RTS is 250, and then RST, so R to S to T, that would be that one there. That's a semicircle. It goes through, this is the diameter right here, so that would be 180 degrees. Here's a couple more sample problems here. Identify the given arc as a major, minor arc, or semicircle, then find the measure. So I'm just going to go through the first part. TQ, that would be minor. QRT, that would be a major. And you can basically tell by looking how many letters it has. Like QS and TS, those are both going to be minors. And the only thing you got to be careful is in case there's a diameter, then it'd be a semicircle if one of the segments is the diameter. TQR, so for example, TQR there's a semicircle, and then RST, there's another semicircle. So when there's 3 letters, it's either going to be a semicircle or it's going to be a major arc. So I'm going to find out what arc SR is quickly by doing 360 minus 120 minus 80 minus 60, so I guess I could just add up those. That'd be 260, so that'd be 100 degrees there, and then I should be able to answer all these questions. These are semicircles, so I know they're going to be 180. So let's start with TQ. TQ is 120. Then we'll go to QRT. QRT, that'd be 240. Everything but 120. And then we have QS. So from Q to S, that'd be 60 and 100, so 160. And then TS would be just 80. All right, then we have congruent circles. So 2 circles are congruent if they have the same radius. Okay, so you can check to see if they have the same radius. 2 arcs are congruent arcs if they have the same measure and they are arcs of the same circle or of congruent circles. If circle C is congruent to circle D, then this would be the congruent statement. Congruent circles don't come up too often, but they are important to show that two arcs are congruent. Basically, let's take a look at number 8 here. I'm going to start with number 8. So they both have a measure of 120, but this arc here, if I were to take this arc and place it over here, you're going to see that this arc is much bigger than that arc there. They're not the exact same. They have the same arc measure, but their lengths are going to be much different. And so that means they're not congruent. So that's the important part. So this would be no, the circles aren't congruent. Okay, this one here, we have congruent radii and the same measure, so that'd be yes, because those two circles, the circles are congruent. And this one here, their arcs are both 90 and 90, but clearly the circles are not congruent. One circle is much bigger than the other, so no, that would be no. And, you know, like I said, if I pick up this arc right here, okay, and I place that over here, these should line up perfectly. I might have to rotate it. Oops. I want to pick up. It's not working out very well for me here. Okay, well, I guess I could use my computer, but I would like to actually show this. So if you, as you can see there, that those are going to line up. I'm glad I spent the full 30 seconds on that. All right, there's your assignment. Pretty simple section. Hope you guys enjoyed, and I'll see you in class.